Physical quantity. A physical quantity is a property of a material that can be quantified by measurement. A physical quantity can be expressed as a combination of a magnitude and a unit. For example, the physical quantity mass can be quantified as n kilograms, where n is the magnitude and kilograms is the unit. Contents, symbols, nomenclature, subscripts and indices, scalars, factors, numbers and elementary functions, units and dimensions, units, dimensions, base quantities, general derived quantities, space, densities, flows, gradients, and moments. See also references, computer implementations, sources. Subscripts and indices. Subscripts are used for two reasons: to simply attach a name to the quantity or associate it with another quantity, or represent a specific vector, matrix, or tensor component. Name reference. The quantity has a subscripted or superscripted single letter, a number of letters, or an entire word, to specify what concept or entity they refer to, and tend to be written in upright Roman typeface rather than italic, while the quantity is in italic. For instance, EK or E kinetic is usually used to denote kinetic energy, and EP or E potential is usually used to denote potential energy. Quantity reference. The quantity has a subscripted or superscripted single letter, a number of letters, or an entire word, to specify what measurements they refer to, and tend to be written in italic rather than upright Roman typeface, while the quantity is also in italic. For example, Cp or C isobaric is heat capacity at constant pressure. The type of subscripts is expressed by their style. For example, by italic style. K and P are abbreviations of the words kinetic and potential, whereas P italic is a symbol for the physical quantity pressure, rather than an abbreviation of the word. Indices. The use of indices is for mathematical formalism using index notation. Scalars. A scalar is a physical quantity that has magnitude but no direction. Symbols for physical quantities are usually chosen to be a single letter of the Latin or Greek alphabet, and are printed in italic type. Vectors are physical quantities that possesses both magnitude and direction. Symbols for physical quantities that are vectors are in bold type, underlined or with an arrow above. If, for example, u is the speed of a particle, then a straightforward notation for its velocity is u underlined, or u, the change in u. Numbers and elementary functions. Numerical quantities, even those denoted by letters, are usually printed in Roman upright type, though sometimes can be italic. Symbols for elementary functions, circular, trigonometric, hyperbolic, logarithmic, etc. Changes in the quantity like delta or delta, the change in y, or operators like d and dx are also recommended to be printed in Roman type. Examples: real numbers are as usual as 1 or the square root of 2, e for the base of natural logarithm, I for the imaginary unit, p for 3.14, 15, 20, 92, etc. Sinus A and sinus H and log x, units and dimensions. Units, choice of unit. Though SI units are usually preferred and assumed today that due to their ease of use and all-around applicability. For example, the quantity of mass might be represented by the symbol m and could be expressed in the units kilograms, pounds, or daltons. Dimensions. The notion of physical dimension of a physical quantity was introduced by Joseph Fourier in 1822. By convention, physical quantities are organized in a dimensional system built upon base quantities, each of which is regarded as having its own dimension. Base quantities. Base quantities are those quantities which are distinct in nature and cannot be defined by other quantities. Base quantities are those quantities on the basis of which other quantities can be expressed. The 7 base quantities of the International System of Quantities, ISQ, and their corresponding SI units, and dimensions are listed in the following table. Other conventions may have a different number of base units. For example, CGS, MKS, System of Units. International System of Units, base quantities. Quantity names: length, width, height, depth, distance, time, mass, temperature, amount of substance, electric current, luminous intensity, plane angle, so solid angle. SI unit name: meter, second, kilogram, Kelvin, mole, ampere, candela, radian, steradian. The last two angular units, plane angle and solid angle, are subsidiary units used in the SI, but are treated as dimensionless. The subsidiary units are used for convenience to differentiate between a truly dimensionless quantity, pure number, and an angle, which are different measurements.